Hi guys, we continue with the topic about gas laws. This time it's Gay-Lussac's law turn. Now let's take a look. Here's the equation that we'll use. As you can see, we are including only pressure and temperature. Initial equals final condition when we relate both of them. Now here are all the isolations that you will probably need for this topic. Now let's do one more example. Let's do the first example, where we have, let's see. Okay guys, let's see. The gas in a container is at a pressure of 3 atm at 25 Celsius. In this type of problems, all temperatures should be expressed in Kelvin. Directions on the container warn the user not to keep it in place where the temperature exceeds 52 Celsius degrees. What would the gas pressure in the container be at 52 Celsius degrees? So we start by writing the givens. Okay, it says that we have initially a pressure of 3 atm at 25 Celsius. And then they're telling me that this container that has the gas in it will be at 52 Celsius. And they're asking me to find the gas pressure in this point. So let's write the givens here. We have initial pressure, which is 3 atm. Initial temperature equals 25 degrees Celsius. We convert this into Kelvin. So initial temperature in Kelvin will be 25 plus 273. This is equal to 298 Kelvin. And then it's giving me a second temperature that is 52 Celsius. Again, we need to convert the Celsius into Kelvins. So we say 52 Celsius plus 273. Three 325 Kelvin. And now, what do I need to look for? I'm looking for pressure in this second condition. So this is going to be my unknown. So looking for the pressure 2, this is the isolation that I have. So I just write the equation here. Pressure 2 equals pressure 1 over temperature 1 times temperature 2. Now I just plug in the values because I have everything. Pressure 1, temperature 1 here, temperature 2 right here. So let's just plug in the values and that's it. I got 3.27 atm. This is my pressure 2. Here the kelvins are those that are cancelled. Kelvin and Kelvin are going to be cancelled. And my final units for pressure will be atm. There you go. Now let's see this example. A cylinder of compressed gas has a pressure of 882 atm on one day. Next day, the same cylinder of gas has a pressure of 4.690 atm and its temperature is 8 degrees Celsius. What was the temperature in the previous day in Celsius? Now take a look here. I'm asking you to find the temperature in Celsius. So this one requires one more step, but again, this topic is still easy. So let's highlight the givens. We have initial pressure and on day 1. Next day, the pressure was this one, and the temperature in the second day was 8 Celsius. So I need to know the temperature in the first day. That means temperature 1. That's what I'm looking for. Let's write the givens. We have pressure 1 equals 4.882 atm. Pressure 2 equals 4.69 or 690 atm. As both are the same units, I don't need to do any conversion here. Now the temperature. Now take a look. This temperature is in the next day. So this is the temperature 2. 8 degrees Celsius. And for every problem, what we do is we convert Celsius into Kelvin. We say Kelvin equals Celsius plus 273, and this is equal to 281 Kelvin. And what am I looking for? I'm looking for the temperature in day 1. This is unknown, but they are telling me this should be in Celsius. So first of all, we're looking for temperature 1. So we're gonna use the equation for temperature 1 that is right here. Now let's write the equation. Temperature 1 equals temperature 2 divided by pressure 2 times pressure 1. We have everything we need, so we need to do just plug in the values. Temperature 2, that is 281 Kelvin, divided by pressure 2, that is 4.69 atmosphere, times the pressure 1, that is 4.882 atmosphere. Here I notice that I can cancel my units, and now I use my calculator. (281 times 4.882 divided by 4.690). So my temperature in day 1 was 292.5 Kelvin. But what happens? I need my temperature in Celsius. As this is a request, that means that we should get this temperature in Celsius. So what we do is a simple conversion from Kelvin to Celsius. So when you have Kelvin, the equation to use, we take the main equation for Kelvin and we isolate for Celsius. So Celsius is equal to Kelvin minus 273. So the temperature I want to change is 292.5 Kelvin minus 273. And now this my temperature 1 in Celsius is equal to 292.5 minus 273. I'm sorry about it. 19.5 degrees Celsius. Voila, that's it. Now the next problems will be about the combined gas law. Now take a look. Combined gas law is an equation that is a little bit more complex, and we have 3 variables in it: pressure, volume, and temperature. Again, for these problems, temperature should be used in Kelvin. Now the 6 possible isolations that we're going to have are these 6 that you can see: pressure 1, volume 1, temperature 1, pressure 2, volume 2, temperature 2. Okay, so according to the type of question is the formula that you will use. Now let's take a look to the first example. We talk about a helium-filled balloon that has a volume of 50 liters at 25 Celsius, and that is also at 1.08 atmospheres of pressure. What volume will it have at 0.855 atmospheres and 10 Celsius? Now we should write all the givens, but before that, let's better identify some givens. So we have the volume of 50 liters, and initially it was at 25 Celsius and 1 atmosphere. Those are the initial conditions. Now, what volume will it have at 0.855 atmosphere? So what we're talking about here is volume that will it have. We're talking about a final volume, and the conditions that will be occurring in that moment is pressure different and temperature different. So we have volume initial of 50 liters. We don't need to convert if the units are not specified in the question, like we did in the example before. We have initial temperature of 25 degrees Celsius. Convert this into Kelvin, will be 25 Celsius plus 273. This is 298 Kelvin. Pressure 1 in that day was 1.08 atmosphere. Now, the second pressure is 0.855 atm, and the temperature 2 is 10 Celsius. Again, when you have Celsius, you need to do the conversion. It's 10 Celsius plus 273 easily. In Kelvin, this is 283 Kelvin. And now, what are we looking for here? We're looking for the volume. The volume 2 is the one that is unknown. So, from all these formulas, the one that is useful to find the second volume is this one. Volume 2. So we write the equation equals pressure 1, volume 1, temperature 2 divided by temperature 1, pressure 2. Now let's take a look. These are, initial volume, initial pressure, initial temperature. You can see them like pairs of givens. So try to see that all your units are the same. Example here. The two pressures are in atm, so that means that we can work on it. The two temperatures are in Kelvin, so yes, we can work with it. And the final unit, which is volume, will be the initial volume, the volume unit that we had before. So let's just plug in the values, the givens. 1.08 atm, 50 liters, 283 Kelvin. All this divided by 298 Kelvin, and pressure 2, that is 0.855 atmosphere. Now take a look here how I cancel these units. Atmospheres and atmospheres are going to be cancelled because they're in opposite positions, and also kelvins with these kelvins. So the final unit, as I told you before, will be in liters. Now we use the calculator to perform all these calculations. 1.08 times 50 times 283 divided by 298 divided by 0.855. So my volume 2 is equal to 59.98 liters. My dog sending regards. Now let's take a look at the last example of combined. A student collects 450 milliliters of hydrogen chloride. Hydrogen chloride gas at a pressure of 100. At a pressure of 100 kilopascals in a temperature of 17 Celsius. What is the volume of the hydrogen chloride at 0 Celsius and 101.3 kilopascals? So, again, we highlight the givens. Initial volume. What will the volume be? So I'm looking for volume 2, and the initial condition was pressure and temperature. The final condition of pressure is 101.3 kilopascals, and the final condition for temperature is 0 Celsius. Okay, so I wrote the givens, and as I told you before, for gas laws we need temperatures to be in Kelvin, so we do the conversion from Celsius to Kelvin. So Kelvin will be 17 plus 273, so this is 290 Kelvin. And in Celsius, this in temperature Kelvin will be 0 plus 273. This is equal to 273 Kelvin. Now, the formula for volume 2 is the same that we used before. So pressure 1, volume 1, temperature 2, divided by temperature 2, pressure 2. Temperature 1, pressure 2, sorry. Just plug in the givens, we have everything we need. And as I told you in the exercise before, just compare that the two pressures that you have are in the same units. Kilopascals and kilopascals, good. Temperatures, both in the same units, Kelvin and Kelvin, good. So my final unit will be the same volume units that I had before. This is milliliters. Let's just do it. 100 kPa, 450 milliliters, 273 Kelvin. All this divided by 290 Kelvin. And pressure 2, that is 101.3 kilopascals. Perform this in the calculator. 100 times 450 times 273 divided by 290 divided by 101.3. So my second volume is 418.18 milliliters. How do I know that? Because I cancel kilopascals and kilopascals and Kelvin with Kelvin. So the remaining unit is milliliter. And voila, that's it. See you guys.